Hello, this is the video for the review worksheet for pre-calc for verifying identity. Some of these will be repeats in some capacity or virtually the same as homework problems or note problems, but that's fine. Still have them all in one nice spot and help you as reference for the quiz that's coming up. So just a quick statement. Remember, we're looking for the most complicated side and trying to make that the simplest. And when we look at some of them, it may be a little less clear which side is more complicated or the easiest to work with. However, I'll talk through some of those issues like I have in the past on other videos to help clear up any concerns on which side to use or what side to work on, what to do with it, and so on. So as I look at this, I see the 1 minus sine x in the denominator, and that cues in my mind to multiply by the conjugate. So therefore, I'm predictably going to work on the left-hand side. Even if I do multiply by the conjugate, it may not be clear what will happen. But nonetheless, if I try to go, okay, on the right-hand side, I want to figure out what to do to, make it look like the right-hand or the left-hand side. There actually is some things we could do with 1 plus sign. We could treat it like fractions, get like denominators, but still, even doing that, trying to get it to look like the left, could definitely be challenging. So we're going to work on the left-hand side. I don't even know if this is going to work. I mean, I do know because I've done this problem many times, but just by trying this, as you do sometimes with trig identities, you may not know exactly if it's going to take you where you want to go. But nonetheless, we know this is a solid process or skill to use in this situation. So let's give it a try. So again, the conjugate instead of 1 minus sign is 1 plus sign. And when we multiply, we're going to multiply in the denominator. For my students, I said if you have 1 plus sign times 1 minus sign, you can go straight to cosine squared. And note, it turns into cosine squared because 1 plus sign times 1 minus sign is 1 minus sign squared. The middle terms cancel since they're conjugates. And 1 minus sign squared is Pythagorean identity, which gives you cosine squared. I highly suggest not distributing in the numerator in any situation first. Distributing the denominator, obviously. But if we don't distribute it in the numerator, we sometimes find that the term that we originally had in the numerator, the cosine squared, with the simplified denominator may cancel in some capacity, and that's exactly what we see here. They're exactly the same. And we see that they cancel, as I just said, and it simplifies to be 1 plus sine x, and that gives us exactly what we want. So then we draw the arrow down. If it didn't, then we look at it and continue with our algebra, possibly other trig skills right there to work forward. All right, for number 2, when I look at this, I want to work on the more complicated side. Obviously, the right or left-hand side is a little more complicated, and we don't have any squared terms. So now that I decide on the left-hand side, I'm going to say, oh, there's no squared terms, so I can't use any Pythagorean identities. However, I know that I can relate all trig functions based on turning all terms into sines and cosines and/or cosines. So let's give that a try. So if I turn cosecant into sines and cosines, cosecant in the numerator is sine in the denominator. Tangent, we use our quotient identity to get it in terms of sine and cosine, and that would be sine over cosine, as tangent is y over x. And now, after I did that trig skill, I'm going to look at it. There's no other trig skills I could do, but now I can look to algebra, and I go, oh, it's two fractions being multiplied. We can cross-cancel. So those multiply, and now I have 1 over cosine x. I look at that and I go, okay, I want to make that secant x. Well, we know that cosecant x, or cosine in the denominator is secant in the numerator. So I can simply just turn that into secant, and we are done. Okay, moving to number 3. So I look to this. The left-hand side is obviously more complicated than the right, so I'm going to work on the left-hand side. When we've seen problems like this where we have two terms we've factored out in the past, however, in this case, there is in the two terms, meaning this term right here and that term, there's nothing they have in common, so we can't factor out, so we can't use that. There's no square term, so we can't use Pythagorean identity. So therefore, I'm just going to get everything in terms of sine and cosine and see what happens. So if I have cosine x, and I know these are going to be fractions because I have a cotangent there, I'm going to turn cotangent into sine over, or cosine over sine. I was right the first time as I was writing. Didn't say it right. Now I got it right. There we go. So cotangent is cosine over sine plus sine x. And I'm just going to look at that and go, okay, well, what could I do? There's really nothing I can factor out. There's no squared terms or anything. I just did a trig skill. So once I do a trig skill, or trig identity, I took something out of our trig toolbox. Then if there's nothing else we could do there, we looked at our algebra skills. So algebraically, the only thing I could do is multiply these together. So cosine times cosine is cosine squared divided by sine x plus sine x. And now I look at this, can't combine like terms, can't do anything algebraically at this point, at least from just in terms of like combining like terms. Doesn't seem quite obvious. So now I'm going to take a step back and go, okay, well, I have two terms here. I have all this term right here. And then I have this term right here. And separated by addition. Well, where do I want to go? I want to get to one term. So I'm going to want to figure out how to add these two together. Well, if I have two fractions, we go to our algebra mind and say, how do I add two fractions together? The way I add two fractions is getting like denominators. So I'm going to put this sine over 1. We see here we have a denominator of sine. We have a denominator of 1. Our like denominator would be sine. So I have to multiply this by sine x over sine x. That's the same thing as if, for instance, we had a denominator of 4 here and a denominator of 1. I multiply by 4 over 4. So let's just go through the process. So now we have a like denominator of sine, so I can write sine x. My first numerator is cos squared x plus this denominator would be sine times sine, which is sine squared. And now there's no like terms, there's nothing we combine. However, what we see is that we have a cos squared plus sine squared in the numerator, and if you don't recognize that right away, what you want to do is look to your Pythagorean identities. Anytime we have squared terms like that, we see cos squared plus sine squared equals 1, so I'm going to change that to a 1, and now we have 1 over sine x, and as I zoomed out earlier, we want this equal to cosecant. It's exactly what we have here. So it wasn't obvious when I was up here that it would get me to where I wanted to go, but I just trusted in the solid skills and using them until I got to a point where once I got to here, I go, oh, I know what to do now. That's what I did in my mind. But still, even if you didn't see it, you could go, oh, well, I'm going to go back to my skills. This plus that equals 1. And now hopefully you see sine in the denominator is equal to exactly what we want, which is cosecant in the numerator. So sometimes it's trusting in the process. Sometimes it's looking ahead in your head. If I did this step, would it get me to where I wanted to go? And if you don't do that, like I said, trust in the process, trust in the skills, and at some point, provided you do the steps correctly, the aha moment in the trig identity will hopefully happen, and you have your answer, or you have your identity verified. Moving on to number 4, here's another two terms on the left-hand side. Sine cubed on the right. Do I know what to do with that? I don't know. So it seems that for this one, we definitely want to work on the left-hand side. And so when we look at two terms like this, we go, okay, what could I do with those two terms? Well, I have a cos squared. I could turn that into 1 minus sine squared. Perhaps that would work. But the thing that I like out of this is I have two terms and they both have a sine in them, so I'm going to factor out a sine. This is just greatest common factor. So if I have two terms here, term 1, term 2, and I factor out a sine, out of the first term, there's only a sine there, so I need a 1 there. As you know, there's always an imaginary 1 times sine x. So if I factor out a sine, there's nothing left. Other than the sine, we need a 1 there. If I factor out sine on the second term, we're left with cosine squared. And once I see this, it's quite obvious to me what's going to happen. But if it's still not obvious to you, you can look at this and go, okay, 1 minus cosine squared. What does 1 minus cosine squared equal? Well, is that a squared term? Can I use my Pythagorean identities? We look back at them. Yes, you can. 1 minus cosine squared equals sine squared. So I'm just going to do that step, and now hopefully, and the other thing with that is we want to finally get a sine cubed term. So if I get a cosine squared term or expression, which I have right here in terms of sine, it's probably getting us in the right direction, or putting us in the right direction that we want. And it did. When I changed this into sine squared, now we have sine squared times sine. That's the same thing as x squared times x. Anything multiplied by itself 3 times is it cubed. So sine cubed is our answer, and we're done. Okay, next. What would be easier, taking one term and turning it into 2, or 2 terms turning into 1? I'm actually going to do this problem twice. First time, I'm going to do it working on the left-hand side. Second time, I'm going to do it working on the right-hand side. So on the left-hand side, I have one full term, and I want to split it into 2. So what I'm going to do is break up the fraction into 2, and we of course can do that when we have, I'm going to put this 1 here, meaning 1 is the first attempt at this by working on the left-hand side. When we have one term in the denominator and more than one term separated by addition in the numerator, that's when we can break up fractions. So that would be sine x and sine x, and then we have a numerator for the first one of 1. The numerator of the second one is cosine x. And now I look, how can I make that look like the right-hand side? Well, this right here is 1 over sine x. That matches up with cosecant because sine in the denominator is cosecant in the numerator. And then cosine over sine is our quotient identity, and that equals cotangent x. And you look, we are done already. So what happens if we work on the right-hand side? If we work on the right-hand side, cosecant x in the numerator is sine x in the denominator plus cotangent, which is cosine over sine. And we do that if we want to combine those, because let's go back to our thinking here. Originally, we have 2 terms and we want to combine them into 1, hence why I put them into fraction form here. And I look at these fractions, I go, oh, look, the denominators are the same. So I could just add them, where you keep the denominator the same in the new fraction as it was in both of those, and add the numerators, 1 plus cosine x, and that is exactly what we want. Next, this one we can also do with 2 terms. Sorry, we could do on the left-hand side or the right-hand side. So let's go ahead and give that a try. What would the left-hand side look like? Go ahead and draw a line here. Left-hand side, I have 1 minus sine x, and I want to get like denominators because these are 2 terms and we want to get into 1. So I'm going to multiply. Actually, I'll go ahead and write this out. I was trying to save myself space working down. That's okay. I'll just write it again. And since this is over 1, I got to get like denominators. And I'm going to multiply this by our other denominator, sine x. So I'm going to multiply this by sine x over sine x. And now I have denominators of sine in both of them. So that gives me sine x in the denominator, and 1 minus sine times sine is sine squared. And now this looks promising, at least in my eyes, because 1 minus sine squared is our Pythagorean identity, and that gives us cosine squared. At this point, because I've done many trig identities, probably much more than all of you have, that I knew once I got to that 1 minus sine squared, I knew at that point I would be able to get where I wanted to go. But now as I look here, what can I do? Okay, so let's say if you, at this point, you didn't see that this would work. I was just, if I trust in the process and turn that into a cos squared, now we may want to just take a step back and say, well, how can I get this to look like this up here? Well, this up here is 2 terms, cotangent and cosine, within 1. So right here I have 1 term. I want to break it into 2 by multiplication. I want this happening, a term multiplied by a term. So I'm just going to separate that fraction and see what I get. So cos squared gets broken up into cos x, and and then sine x in the denominator. One of the denominators would be sine, and one of the denominators would be cosine. And as I do that, I now see that cosine over sine is cotangent, and then cosine over 1 is cosine. Alrighty, so now working on the right-hand side, there's no Pythagorean identity here. So I'm just going to try to turn everything into sines and cosines and see what happens. And if you look at this compared to the last one, this really is working backwards. So from what, like, seriously, if you look at this left-hand side, we're probably going to have like the exact same steps in complete reverse, the other steps in reverse order. So as I do that, I now go, okay, well, cosine times, there's nothing else I could do other than multiply those together, and that gives me cos squared. And now some insight would tell you, saying, obviously, if you're doing this problem and you don't have the left-hand side in front of you, I look at cosine squared and I go, okay, well, cosine squared I can turn into 1 minus sine squared. I'll just give it a try. And look at this, 1 minus sine squared over sine x breaks this up into two terms. And now I can break this up into 1 over sine x minus sine squared x over sine x. And this looks really nice because 1 over sine x is what we want for the first term. In the second term, we want sine x. Well, I just cancel those. Sine squared over sine reduces the sine, and we have our final verification. All right, so on this one, these look very, very similar to each other in terms of difficulty level, but the thing that cues me in my mind to work on the left-hand side, or preferring to work on the left than work on the right, is the fact that I have those two terms in the denominator, and therefore I'm going to multiply by the conjugate. I'll still show you what I'll just talk about what you can do on the left-hand side, or on the right-hand side, but I'm just going to do the left-hand side as it definitely would be the most preferable in my opinion. So I multiply by the conjugate, just going through the steps. I know in the denominator I'm going to get cosine squared x. Again, I'm not going to distribute in the numerator just to see if there's any sort of canceling. And when we do this, we see we have a cosine x in the numerator and a cos squared in the denominator. It's all in terms of multiplication, meaning I have one whole term times a term divided by a term, so I can go ahead and cancel. And so now in the numerator, after I cancel, I have 1 minus sine x over cosine x, and that's exactly what we want. And we are done. If we look at the right-hand side, your first thought, at least my first thought, might be to separate into 1 over cosine minus sine over cosine, separate into fractions, but we want one whole fraction here. So my suggestion would be, if you wanted to work on the right-hand side, is multiply by the conjugate of the numerator, because when we do that, hopefully we'll have the same sort of like mathematical relationships between numerator and denominator that we had over here. We'll have the same over here, and that's exactly what will happen. So I suggest following up with me if I'm your teacher or your teacher on that if you decide to move on to if you decide to work on the right hand side. 8, this one I did in class, but I am going to do it again here. If I look on the left hand side, I have 2 terms. On the right hand side, I have 2 terms within 1, so we can think of it as 1 term. So this one I'm going to work on the left hand side by getting this into sines and cosines, so we have 2 fractions, and when we have 2 fractions now, we can get like denominators, and hopefully we have nice things happening from that. So when I now have this, at this point you're not going to be able to see how this is going to turn into secant cosecant, but again, this is one of those problems where you just trust in the process and do the proper trig and algebra skills to hopefully get to a point where the aha moment where we go, oh yes, I know what to do to get it to look like that. So I'm going to get a like denominator, so my denominator is cosine here, my other denominator is sine, so we would have to multiply the cosine by the sine, and the sine by the cosine in order to get like denominators. So I'm going to multiply that by sine over sine. I'm going to multiply this one by cosine over cosine. And now I have like denominators. So my like denominator is sine x cosine x. And in my first numerator, I have sine times sine, which would give us sine squared, plus this numerator, cosine times cosine, is cos squared. Sine squared plus cosine squared, I want to look for Pythagorean identity. It equals 1. Now I have sine over cosine. We can break that up into two fractions, 1 over sine times 1 over cosine. Sine in the denominator is cosecant in the numerator. Cosecant in the denominator is secant in the numerator, and that's exactly what we want. I think the order might have been backwards, but which is fine. It's exactly the same. A times b is the same as b times a. All right, so in this one, definitely the left-hand side over the right, because I have these two binomials being multiplied by each other. I have different approaches that I could take. I think it would be best if we did distributive FOIL. The other would be, I have a cotangent squared plus 1 that could turn into a cosecant, which could get us some really interesting things. As then we have a cosecant squared, which is 1 minus sine squared, and distribute that in. We may be able to get somewhere, but I really think that, especially over the fact that we have a cotangent squared over there and a plus 2, we might get some interesting things happening if we do foiling. So I'm going to foil and see what happens. So if I foil this, and first step is this, I'm just going to write it out and see what it looks like. So I have a cotangent squared times sine squared. Second, cotangent squared times 1, anything times 1 is just itself. 1 times sine squared, I'm going to distribute that in, times sine squared. And then a 1 times a 1 gives us a 1. So how am I going to work with that? Well, I look at where I want to go. I see I want a cotangent squared plus 2. Well, if you look here, if we do some investigative work, we already have our cotangent squared. So maybe that might just be that cotangent squared, and all this other jazz here turns into 2. Well, I have a 1 here, which means 1 plus 1 gives us 2, so this plus that should equal 1, because then that 1 plus 1 would give us our 2. So with that being said, let's see what we can do with this. Cotangent squared in terms of sines and cosines, because I want to simplify this. I don't want to turn it into its Pythagorean identity. Let's see, cotangent squared is cosecant squared plus 1. Might not want to do that. Let's try this. Cotangent squared over sine. I'm not saying that it's not right. This is just what I'm decided to do. I'm going to try that. Rewrite the rest of it. And now I look at this and I go, okay, in this term right here, I can cancel the sine squareds, and I'm left with a cosine squared. And again, I'm just going to write it out. And after I write it out, do my thinking. Okay, now this might be a little more obvious. Again, the cotangent squared matched up, so I'm just going to go ahead and rewrite that. And then we know that if I take cos squared plus sine squared, that's a Pythagorean identity. Cos squared plus sine squared equals 1. So to kind of illustrate that, you wouldn't have to write those crossed out, sine squared plus cosine squared, in my opinion. But I'm just indicating that that 1 came from those added together. I have this other 1 here. Oh, whoops, I forgot the x for the cotangent term. And so now the 1 plus 1 obviously equals 2, and we're done. Now, coming back up to here, if you went 1 plus cosecant squared here and then distributed in, you would get a sine, let's see, cotangent squared plus cosecant squared. That times that would have given you a sine squared, and that times the cosecant squared would have given you a 1. And that I don't know. I don't know where that would have gone from there. We could explore it more, but I think this way is undoubtedly the most efficient. All right, I think this one is definitely a lot more straightforward than other ones we've seen. no squared terms, going to work on the left-hand side. Since there's no squared terms, we are simply going to take that cosecant, turn it into 1 over sine. And now cosine x over sine x, I'm just going to combine those together. So that would give us cosine x over sine x, which is equal to, based on our quotient identity, cotangent x. All right, again, on this last one, I think a lot more straightforward. I think we definitely are going to work on the left-hand side. As I look at the left-hand side, I see I have cosine times secant. Those are reciprocals of each other. Reciprocals being multiplied always give us 1, but if you don't still see that, because we're in the context of trig expressions, trig functions, versus just like 4 times a fourth, for instance, let's see if I switch up this 1 over secant. Note it's in the numerator of the large fraction, so in the numerator of the large fraction, we have 1 over cosine. In fact, you could have put cosine in the denominator as well with the cotangent. And now when we do this, we have, sorry, dishes in the background, noises, my apologies. When we do this, we have cosine over cosine cancels, and so in the large fraction here, we have 1 over cotangent. And we don't even have to go in terms of sine and cosine. We have 1 over cotangent. We want to get to tangent. So cotangent in the numerator, cotangent, in the denominator equals tangent in the numerator. And we are done.